Hello, everyone. Bonjour, welcome. This is a session titled Microbit and Sugar Bush. The Ojibwe word for sugar bush is iskigamizigan. And in this session, we're going to take about 50 minutes to tell you about a lesson that Andy and I have taught and share with you some resources that you can use to teach the same lesson with your students. So in this session, we are going to give you a little bit of a background about the, I guess I have to click admit unless one of you are able to do that. All right, one of you able to admit people as they, all right, I'm going to try to do this as we go. All right, welcome everyone. So in this session, we're going to give you a little bit about background about our project with Sugar Bush. We'll give you some context and background and an overview of the project. We have an activity for you where you'll get to use Microsoft MNCodes and do some of the activities that we had fourth graders do. And then we'll share with you the outcomes of what we have learned in the couple of years that we've been teaching this lesson, and then share some resources with you. So I'm Paul Schonfeld. I'm the district support coordinator at the Northern Lights Collaborative for Computing Education. That's based at University of Minnesota. I am not native. I am white. And so all of the context for Ojibwe language and Anishinaabe culture that I have learned through this project has been through partnerships with people involved with the grant that I'll tell you about, and teachers who are involved at the Fond du Lac Ojibwe School. But I work for University of Minnesota as district support coordinator. Andy, you want to introduce yourself?
Yeah, thank you, Paul. Hi, everybody. Andy Olson. I am a K-4 technology integrationist at Hermantown Elementary School. And I like to use this picture because I think it kind of captures my attitude of when I'm not at work, I'm always outside. And that's kind of how this connection came with the sugar bush and computer science. All right, so today what we're hoping to accomplish is we want to show you some possibilities of ways that you can integrate computer science into what students are actually learning. We want to also find ways to make those real-world applications to intertwine computer science. And then we also want to have inclusive and culturally relevant lessons, specifically in this lesson, connecting with the Ojibwe culture and language. And then we also want our audience and students to gain familiarity of using microbits as physical computing.
All right, a little bit of a background about this project. This project is a collaboration between a variety of school districts and the team that I work with at Northern Lights Collaborative for Computing Education. And it's also an NSF grant. So the districts who have been involved in the first years of the grant were Hermantown, where Andy works, and the Fond du Lac Ojibwe School. And now we have expanded the districts involved in the grant to include a couple of other districts, Duluth Public Schools and St. Louis County Public Schools. And I just want to share with you now a little bit more about the grant itself. So this curriculum that we're going to describe has come about as a part of an NSF grant working with rural and tribal schools to build K-12 pathways. There was an old grant that was completed last year. It was a 4-year grant that involved Fond du Lac and Hermantown. And now we have started a new 4-year grant that involves currently 2 more districts, and we're looking for an additional 4 districts as well. So if you or anyone that you know would like to get involved in building a K-12 computer science pathway, we're looking for more districts, and I'll drop a link at the very end where you can fill out a form to say you're interested. But yeah, a part of this grant has been developing district visions and having conversations with districts from rural and tribal schools. And as part of those conversations last year, some teachers from Fond du Lac Ojibwe School said, could we use microbits to collect data and better understand sugar bush and incorporate traditional ecological knowledge with sugar bush, as well as using computers and microbits to collect and analyze data. A focus of the grant is to identify the needs and supports for historically marginalized groups. That includes American Indian students. A little bit of background about Anishinaabe people and the Ojibwe language. So Anishinaabe people live in a wide swath of area around the Great Lakes and have lived in this area for a long time. And I'll refer to Ojibwe language. Ojibwe people are one of the groups of Anishinaabe people. And as I was alluding to, it's a very large tribal population. It spans across parts of the United States and Canada. And so we developed this curriculum with hopes that it would make culturally relevant computer science content for a wide group of people who are marginalized in computer science education. Andy?
All right, so just a little background at this whole process kind of got started through the collaboration of the grant. And so we've learned a lot from the Fond du Lac Community School, where we partnered and shared ideas. So the idea of a sugar bush is where you are having a group of sugar maple trees that are used to produce maple syrup or some kind of product from the maple syrup. So this little map here just kind of entails the Fond du Lac location. And basically it's just the pathway of where they have tagged their trees. And then the star shows the boiling station. At our school, it's very similar, where you have our sugar bush trails, and then we have ours marked as well. And then we have what's known as like the sugar bush camp. And that's where we do all our boiling and things like that. So I don't know if anybody has been involved in collecting or making their own maple syrup before, but if you have, go ahead and throw it in the chat. It's a very interesting process. Prior to us doing it at the school, I've had personally 2 years of experience of doing this on my own. And so we incorporated some of the things that I've done, along with learning from the Fond du Lac schools, to get this going. A lot of the questions that get asked are timing. It's when do I tap the trees, and when do I know when to stop? So timing has many factors of this, but typically it revolves around temperature. You want those temperatures that are below freezing at night, but then they go above during the day. So they kind of warm up the trees, and they basically re-energize the trees to produce sap. So it's also very interesting because we invite a lot of our families to come in, and everybody does it differently. So it's just kind of cool to see. This is a picture from our school, and this is how our outdoor educator runs his sugar bush. He uses the metal taps where you hang this frame with the blue bag, and then the students every hour go out and collect the sap, bring it back to the sugar bush camp, and then after we collect a certain amount, then we have a boiling day. So typically where we live in northern Minnesota, it happens mid to late March is when the trees start to run. And typically it's like a 4 to 6 week process of when they go from start to finish. There's a lot of ideas that are out there about when it's done. I kind of run off the idea of they kind of turn, the smell kind of turns, and it gets kind of foggy, the sap does. So the sugar bush process, it really is nice like doing it at the school because it's a team effort. So we have kids helping collect sap. Um, Mainly the teacher maintains the fire, but the students help with the boiling process of stirring the sap as it boils and filtering it. And then they also are able to help with the final boil that we do as well.
And on the same slide, I just wanted to add that a couple of the things in the picture that you see are resources that we've used with teachers and students. The Sugar Bush coloring book has background and context of Ojibwe language and culture as it relates to sugar bush, made by Cassie Brown. And then the book on the right also tells the traditional Ojibwe story of sugar bush as well. And I was also going to mention that, a couple of pieces of traditional ecological knowledge that are included in the unit guide that we'll share as a resource include, when to tap the trees, things like listening to birds and paying attention to the snow, and when to stop tapping as well. All right, so this lesson that we're going to share with you and the overview of the project we're going to tell you about, we designed this unit and incorporated it with a 4th grade class. And we've designed this to span over 3 lessons in the case where we were implementing it at Hermantown. It does take more time to actually do the sugar bush itself, but the microbit component of it we developed to span 3 lessons. And in those lessons, students are covering things from social studies, from math, from science. So the approach of this unit is to integrate computer science with those classroom standards in math, science, and social studies. So in social studies, students are learning a bit about Ojibwe culture and language through some activities each day. In math, students are learning about data collection and analysis, where they're analyzing maximum, minimum, average. They're doing some algebra, they're doing some graphing, so they're covering some standards in those areas of math. And in science, they're making inferences as they analyze the data. They're doing some problem solving, and they're looking for patterns in the weather. So as they collect data about temperature from microbits, they're looking for patterns over a larger span of time and seeing if they can correlate that with what's happening with the trees outside and the sap that's being collected. It's a cross-curricular learning experience. So at Hermantown, it involved all of the kindergarten through 4th graders, where they would go outside for outdoor ed. They would experience the sugar bush. They would collect sap. They were using the coloring book from the previous slide and having some exposure to Ojibwe language. And then in the 4th grade was where they did the most computer science. And this is where we had all of the 4th grade classes this year do a 3-day unit that we'll highlight here in the next few slides. But they were using microbits while also going out to the sugar bush and collecting sap and syrup, making syrup. And then there was a component in the high school as well, where we had students in the computer science principles class using MIT App Inventor for what they called the SAP app challenge. And they had the high schoolers making an app that could be used to collect some of the data as they went around and collected sap from the different trees. So those students built an app to collect data, but we'll highlight mainly the 4th grade component of the microbits plus sugar bush. Andy?
All right. So as Paul mentioned, we designed this unit to be a 3-day integration unit where we push into the classrooms. So we kind of broke it down into day one was tinker and explore and get interest. Day two is making connections. And day three was go ahead and finish the project with the field testing. So back to the tinker phase of day one. Paul and I did a lot of pre-planning on this, and we bounced some great ideas off each other. And so we decided to pose each day with a starter question to our students. And the one thing that we really wanted our students to make connections was is using technology to accomplish complex tasks. So that was our focal question that we used for day one. And so basically that segued us into getting the students to use microbits hands-on. We landed on microbits mainly because that was a resource that was readily available to us. And so we already had some that the students could individually use. And then this year, because we expanded the project to 6 classes, we did a lot of paired programming just to use the resources that we had. So as you can see in the picture, some of it was a little bit of us showing and sharing and teaching some experiences, but then the main part of the lesson of day one was getting this device in the kids' hands and letting them experience this for themselves. So day two, where we focus on making connections, that is where we're integrating more of the Ojibwe language and connecting the sugar bush to integrating computer science. So this was kind of a fun day in the lesson because you started off and you say, who knows how to convert Celsius to Fahrenheit? And all the fourth graders are just, what is Celsius? What is Fahrenheit? And so then we kind of have those genuine conversations, but then we go through the formula that you see there, and every student does one with me where we convert Celsius to Fahrenheit, and then we give them one challenge problem to try and convert Celsius to Fahrenheit on their own. And so this was a really good of anyone can do this. We did it together, so everyone finds success. And then the challenge of them having a bonus one is just offering that extra rigor for those students that wanted to try it again. So I like this part of the lesson because we kind of start it with hands off. It's all pencil paper, because that's how I like to do math sometimes, is old school paper pencil. And then we go ahead and make those connections of how can we use microbits to help us understand and interpret weather patterns. And so it might be on the next slide. And this is a great idea that Paul will explain more in depth. But basically, we use that formula to then go ahead and use MNCodes to have the students use the MNCodes website to program a microbit to convert from Celsius to Fahrenheit. And I might have skipped this or wasn't mentioned yet, but the reason why we have to do this process is because the microbit device can only tell temperature in Celsius. Is that correct, Paul?
Yep.
Yeah.
Yeah, you want me to talk about this slide a bit?
Yeah, sure.
Sure. Yeah, so on day one, the goal with the students was to get them using a microbit and transfer code onto the microbit. So they did a flashing heart. We'll give you a chance to try out these activities in a few minutes, but we kind of verified that they could do a sample program, flash a heart on the microbit, and transfer the code. Day two here, we gave them some starter code, and we teach them a little bit about the inputs and this temperature conversion. And so we give them this starter code, and after going through the conversion, teach them a little bit about some of the basics of dragging and dropping blocks inside of blocks in Microsoft MNCodes. And the goal on day two is for those students to then modify this program to get it to convert Celsius when button A is pressed. So the microbit will display the temperature in degrees Celsius when the button A is pressed, and when button B is pressed, they're working through the math and the arrangement of the blocks here to get it to convert that temperature in Celsius to a temperature in Fahrenheit. So we walk them through that process using this starter code. Oops. Yeah. Okay, next slide, Andy.
All right. So at the end of that day, then we kind of lead them into where are we going next? Why are we doing all of this? And so then we leave them with a picture on the left where we place a microbit outside their classroom to collect the temperature readings. And then we have a second device that is on the other side of the window on the inside that receives the data. And so what our plan with that is this is where the teacher, as you can see in the picture, takes over on day 3 to explain more of the connecting of what we're doing into a 4th grade setting of connecting it with their math standards. And so we decided to use collecting averages and graphing. Something that kind of came up from year 1 to year 2 was year 1, we only had one class do this project with us as kind of like a test. And this year it elevated to all the 6 sections wanting, or 6 classes wanting to do this with us. And so we decided to compare data results from classes across the hallway, which gave some really cool results. So this visual that you're looking at is how the data is collected from the microbit device. So after you download the device or the information that was received, this is what it'll look like. And it will also give you a Excel view where you can see the results that is a little more user-friendly that we take from. So in here, what I do to help the teachers make this a little more successful is I take the results and I organize it for them. And then the classroom teachers would use this as their morning work. And so every kid, as they came in, they would find, and they would simplify this so there was only one reading every hour, and we only used the days of the hours of the day. And so there's less temperature readings, but they would average it out, graph it as their morning work as they came into school. So this was a graph that we used to compare the 2 classes. And this is where the science piece of inquiry and understanding is. You can see the temperatures and all the teachers were getting upset at first because the temperatures were so high. They're in the hundreds. And obviously the temperatures in northern Minnesota in March and April never hit 100. They barely do in July. So we had to troubleshoot and figure out some different ways to find a better solution. And so instead of us just doing it, we flipped it back on the students to give us some possibilities of why this is happening and what else could we try. And so some of the solutions were we use Ziploc bags. And so they came up with a theory that the bag was basically giving the greenhouse effect where it was heating up the device. It was getting too hot. Some classes said the window was causing the microbit to retain heat. And so some of the solutions were poking holes in the bag, trying to move the bag lower on the window so it wasn't actually touching the glass. And then another class decided that they wanted to move theirs into a shady location. Because as you can see, the blue temperature readings, they were on the shady side. So it was a positive moment for us to just do some real world conversation of troubleshooting, problem solving, and looking at possibilities. So
Yeah.
Go ahead, Paul.
Yeah, just to introduce this poll, we wanted to gauge from you who here has used microbits before. So, and that can kind of inform how this activity goes. But if you would enter in the chat, or you could unmute yourself and just let us know if you have used microbits before or not. And if you want to expand on that, you can. But we're curious who has used microbits before. Okay. Okay, good, good. All right, a few of you have used microbits, but might not have the microbits in your lab. And the activity we're going to do here does not involve physical microbits, but just the online simulator. So Andy, do you want to explain what we're doing here?
Yeah, sure. So on the next slide, and we'll share some of these links out, but on the day one, we have all the students go to this MakeCode editor website. And so down below, you'll see the tutorials. And so we encourage every student to start with the flashing heart tutorial. And then as they finish, they check in with one of the adults in the room, just to verify that they had success or if they have any questions. And a lot of times, just as a classroom teacher, if a kid comes up to me and says, I'm having trouble, then I'll offer this other students to go and be support, rather than me rush to help everybody. I'd rather them learn from each other. So after they finish that flashing heart, we encourage them to use the rest of the time that they have with us to try any or as many of the other tutorials as they can. And it's just a really easy, super fun. The kids have high energy to make this process. And then they actually, with that paired programming, they actually get to use the microbit device, where they send their program to the device so that it operates how we're going to have it function. So we can just quickly, briefly show the MakeCode website. I don't think we need to do any of the tutorials, Paul, but we can just kind of show, as this is a really great starter, easy way to get people in.
Yeah, so I'm going to drop a few links in the chat. I also just dropped a link to the slide where you can click on those links that are embedded. But we wanted to give you here about 8 minutes or so to explore these resources that we've created. If you're new to microbit, perhaps start with any of the introductory tutorials. But if sounds like most of you have used microbits before, the other links I'm going to drop here directly include the one that we mentioned with the temperature conversion starter code. So if you choose that one, why don't you take the next up to 8 minutes to see if you can modify the code to make that convert Celsius into Fahrenheit. And then Andy mentioned as well that the other code that students are using and seeing, but is this transmitter and receiver code. So if you want to see the code that is used to transmit temperatures from outside of the classroom and have those be received and stored on the microbit that's inside the classroom, you can take a look at the transmitter and receiver code. But we want to give you here, the next 7 minutes or so to investigate those programs. And I'm going to click on one of them here, like the digital thermometer. And if you click on the edit button, you can try to rearrange this. So for example, just to display the temperature in Celsius, I can rearrange these blocks. And on the simulated microbit, it's going to say that it's room temperature, 21 degrees Celsius. And we'll give you some time here to experiment with this program or the other ones. So here's the transmitter code. But we do want to give you some time to just investigate these programs. Pop your questions in the chat. And at 12:10 here in about 5 minutes, we'll come back and resume. Andy, anything else you want to direct people to do in these next 5 minutes?
No, but I think as a teacher, just kind of going in and editing and seeing and reviewing how Paul set up the notes, I think is kind of neat. So if you, obviously a lot of you have experience with microbits, go ahead and explore those and just see this is a really fast way to get your kids into accomplish a task without a lot of that initial setup.
All right. Now that you've had some time to explore some of those resources, I'm wondering if anybody wants to drop a note in the chat or unmute to say what were some things that you noticed or wondered or explored in that short amount of time that we had to check out some of those microbits activities and resources. Okay, for the radio programs, is there a way to simulate receiving a message? Not that I have encountered personally. That's one that I've only had success with the actual physical devices. I think with some creative thinking, perhaps there is a way to simulate that sending and receiving of messages. Thinking back to teaching computer science principles with the code.org curriculum, there was a curricular unit about sending and receiving messages where there was an online interface and students learned about IP addresses, and there was a simulator there. That's a related lesson that perhaps could be used, but I wasn't able to do the radio programs simulating receiving a message in the couple years that we've done this so far. Good question, though. All right. Anybody else?
Paul, maybe something that I'll just add to kind of close out that day 3 of when we leave and show them the transmitter code, set up their device, practice graphing and collecting data, is we leave those 2 devices in every room for about 2 weeks. And so we get the kids involved with having them be responsible for bringing in the outside device, because the first year we ran into a lot of battery problems. So they bring in the outside device every night, and then we set them up in the morning. So a kid gets that job of setting them up. They have to bring me the receiving device every day at the end of the day, and that's where I would put it into a spreadsheet that's user-friendly for teachers. So it was a lot of good conversations that were happening and a lot of roles and responsibilities to get the students more involved in the process. I would say during this 3-week, 4-week process, a lot of the 4th graders would ask me tons of questions or say, how come we only had this many readings? Why was it so high? It was a really cool experience.
And as you have other questions, feel free to enter those into the chat, and we'll leave some time for Q&A at the end as well. So sharing about some of the outcomes, what happened in these couple of years that we have been trying out this lesson with 4th graders. So I'm going to highlight some of these outcomes here. All right, so one of the categories that I want to describe as an outcome was this great experience of inter-school collaboration. So the 2 districts that were most involved in the development of this unit were Fond du Lac Ojibwe School. We can see Jody and Brittany shown in the middle here. In Hermantown, we've got Andy and Joe, who visited the Sugar Bush setup at Fond du Lac Ojibwe School. And there was some great collaboration. We learned a ton about traditional ecological knowledge and traditional ways of doing sugar bush, and we tried to incorporate those into the unit plan and the unit guide, and integrate those with the computer science learning activities that came about as a part of the project. Another outcome and resource that came out of this unit was this unit plan and teacher guide. I'll drop the link in the chat again. But this is a resource that you can share with whoever you want, anybody that might want to do this lesson. And this more comprehensive unit plan brings in some more context and list of materials, kind of a day-by-day plan for teachers to use, and an explanation for each of these activities and how to set it up, strategies for incorporating Ojibwe language and culture. And yeah, it's a multi-page unit guide that you can use and share with people who might want to try this out in their own setting. We also recognize that not everybody can create a physical sugar bush setup at their place, so there are some simulation tools in this as well, where you can get a simulated data set and have students analyze that simulated data set if they can't actually set up the sugar bush themselves. So again, with this inter-school collaboration, we worked really closely with Jody Loughlin from Fond du Lac Ojibwe School to share the ways that they've been doing their sugar bush, and Andy has done sugar bush himself as well. Oops, that's me clicking on the link. Other outcomes and resources included this K-12 learning. We mentioned that at Hermantown, the elementary school kids would go out to this sugar bush every day. They would use this sugar bush coloring book. I'm gonna just click on the link here by Cassie Brown. And yeah, that was one of the tools used for learning Ojibwe language and doing some activities, learning about traditional ways of doing sugar bush. And then we had the high schoolers making apps as well. So this is a picture of that SAP app that was mentioned, where students were using the mobile CSP curriculum and developing mobile apps that were then used to collect data and save that data. And actually, Andy, I see that I've got you mentioned for this one. Do you want to talk more about this one?
Yeah. Do you mind switching the tab over to the slide deck?
Yep, 1 second. Go for it.
Perfect. All right. So just to get more out of this unit, we have a college and schools computer science course that is being offered. And one of the teacher that was running the class, I presented them with, what if we offered a way for them to use this design thinking process to help us create a SAP app to track how much sap we're collecting from the trees each year. And so we kind of posed it as the outdoor education teacher and myself were the customer, and the students were the app developers. And so the first year we offered it out as a Shark Tank type style of challenge, where they broke off into teams of 2 and 3, and they came back together. And at the end of that, in year 1, we decided that we liked bits and pieces from all of them. And so we challenged them to kind of morph their ideas into the final SAP app. So there were some things that we liked. I think the timing of it was challenging. So we went back again in year 2 and we offered the same challenge, but we were more specific in what we were looking for. And so again, we went in with that customer role of here's what we want, here's the deadline. And so one of the things were we really want them to field test this, because the first year everything worked great in the classroom. And then they came out to the outdoor classroom and they're like, well, there's no internet out here. And we were like, oh, okay, so we should do some more field testing. So the second year we built in more field testing where the high school students come down into the woods, they test out their product. This year they actually then handed the device off to 4th grade students, because our outdoor educators basically said, if the kids can't do it, then I don't think there's a point in us doing this. Like, he wants the kids to be able to input, use it. So it was very kid friendly. And then they use this application and it will then send it to a spreadsheet, which we could track from year to year. So I think we're going to continue with it again in year 3, and again to challenge to have them refine it even more. So they'll maybe be focusing more on the GPS focus or the map feature. So that's something that's exciting going forward.
All right, we wanted to share a few more outcomes and then also leave time for Q&A and some resources. So this is one of the outcomes of the project. There was kind of this need, as Andy mentioned, to house the microbit on the outside of the window. So this was a 3D modeled microbit, custom made 3D printed cover. Students were noticing some of those temperature spikes and said, I've heard that black absorbs more heat. What if we 3D printed it in a lighter colored filament? And those were some of like the problem solving steps that we saw come out of this project. Students having great questions about why did we see this in the data and how might we address the design of the device itself. So here's a picture of it, the unit suction cup to the outside of the window. And I personally have a 3D printer at home and was able to just print some for Andy and bring them over. But Fond du Lac Ojibwe School has some 3D printers as well. And yeah, this is a short video I want to show you, just showing the students doing daily collection of data. I'll play this here to see what it looked like.
7.
What happens when you press button A?
A gives you the, I think A gives you Celsius.
In that Fahrenheit?
Yeah.
Show me the Fahrenheit. Thanks. So yeah, that shows them using that code that they explored, and then the kids would go out there as they went out to the sugar bush. This was last year, really deep snow, and they would use that data that they collected each day with temperature as well. At Fond du Lac Ojibwe School, they actually did not do the sugar bush last year or this year out of respect for the trees. And it had just been a really harsh winter and some unsafe conditions for getting around in the deep snow last year. And then this year with the weird weather that we had, they decided to give the trees a break and a time to rest. And that was part of the respect and the grandfather teachings that were important to being aware of, the health of the trees and incorporating that and being adaptable to the environment itself. And yeah, as I mentioned, the conditions were not great last year at Fond du Lac Ojibwe School. There were a lot of downed trees, so it was just hard for students to travel around in the deep snow and with some fallen trees. So they decided not to tap the trees last year or this year with the strange weather that we had. And another outcome was just some professional development with each of the schools, some custom PD as well as some all-school PD. Lessons learned, big picture, that we had to be adaptable, adapt to the circumstances. I mentioned this lesson of respect and having humility for the weather and learning about these grandfather teachings, including respect, and using that to inform the project and decisions made as they affect the health of the trees, etc. And then that this whole project is an evolution. We learn new things each year and try out different things. A couple of technical lessons learned included batteries. We found that lithium batteries lasted a lot longer, especially in that cold weather. Rechargeable batteries worked fine too this year, and Andy had a nice schedule to replace them so that they wouldn't die prematurely. We found it was helpful to give students starter code to adapt, and then had some adjustments of the microbit case for durability. And Kathy, thank you for your comment. What a great application of learning and real world skills. Absolutely. So finally, here on these slides, I'm going to, again, drop a link to the slides here in the chat so that you have access to all of these resources, including the books that I mentioned, the 3D printing case, and more. And then if you or your district, or if you know anybody that would like to be involved in this grant, we're definitely looking for new schools, rural and tribal schools. So I just dropped a link to an interest form that you can pass along to anybody who might like to be involved in this grant. Another thing coming up with some similar curriculum is a PD session being offered virtually on April 24th about Three Sisters plantings in computer science, where this one's designed for teachers in grades 5 through 9. Stipends available, and you can pass along that sign up link to anybody. But I also really just want to say thank you, Miigwech. And I know that we're basically at or a little bit over time, but want to offer up opportunity for questions and say thank you for attending. So thanks everybody for being here, and you can unmute if you would like to. I will pause the recording.